Okay, the next thing we're going to talk about is the characteristics of a quadratic, but when the equation is in vertex form. So up to this point, you've basically only been dealing with quadratics in standard form, but sometimes we see them in vertex form. Both forms have their advantages, and so we're just going to look at the information we can get from this one. So first of all, is there a reflection here? And the answer is no. How you're going to know if there's a reflection or not is if there's a negative in front of here, okay? Horizontal translation. Horizontal translation is always appears inside the function. It's what is affecting the x. So if you think that this is a horizontal line, is this the x-axis or is this the y-axis? This is the x. So horizontal translation affects the x and it's right next to the x. So hopefully that should make sense to you. The horizontal translation is going to move this 3. Now this is the part that seems to mix people up. Basically you're saying, what would I need to make this 0? Positive 3. So you actually are going to move 3 to the right. Okay, so you're going to move 3 to the positive direction. Okay, so that upsets people because it's a -3, but it's going to move 3 to the right. The vertical translation. So vertical line is like this, so it's affecting the y. That's the y-axis. Moves, and it's right here, up 2. Okay. And it is as it appears. So that's how we read a quadratic in vertex form. Horizontal translation comes from in here. Vertical translation comes from in here. If this is a negative, it moves to the right. If it's a positive, it moves to the left. If this is a positive, it moves up. If this is a negative, it moves down. And the best part about this is the vertex is right there, because if you think about it, an original graph, y equals x squared, has a vertex at 0, 0. So this is a quadratic that has been transformed by moving 3 to the right and 2 up. So if I moved 3 to the right and 2 up, my vertex is now the point 3, 2. So the huge advantage of this form is that you can just see the vertex right there. It's right in front of your very eyes, okay? So the equation of axis of symmetry is still the same as it was before. It's always the x value of the vertex. We can answer the opening and maximum and domain and range. How about once we've done our graph? I like to look at it visually before I answer those. Y-intercept. People make mistakes here. They say, the y-intercept is 2. Well, look at this graph that we just did. Does it look like the y-intercept is 2? When it's in standard form, you just look at the c value, but this is not standard form anymore. A y-intercept is when x is 0. So we need to do just that. We need to set x equal to 0 and solve for y. So -2 squared is 9, and 9 plus 2 is 11. So I actually have a y-intercept where x is 0 and y is 11, okay? If you remember the mirror point we get from looking at the vertex and looking at the y-intercept. So if the vertex is 3, 2 and the y-intercept 0, 11, my mirror point is going to be 6, 11. Okay, so let's go ahead and sketch this now. I'm just going to erase this. Sometimes too, if you want, do the mirror point once you've done your graph. Maybe it'll make more sense to you. Okay, so my vertex is 3, 2. My y-intercept is 0, 11. My mirror point is 6, 11. Things are looking pretty good. I had expected this to be not have a reflection, so it makes sense. So it opens up. It is a min because the vertex is the lowest point of my graph. My domain is XER, as it is for every quadratic in the whole wide world. And my range is that y is, I always look to the y value of my vertex to get my range. So 2 are all my y values bigger than 2 or less than 2. All my y values are bigger than or equal to 2. So there you go. So there's an equation in vertex form, okay? So just real quick, x minus h squared plus k. So if I have x minus h in there, then I am going to move to the right. And if I end up with x plus h, I'm going to move to the left. Okay, and if I have a plus k, I'm going to move up. And if I have a minus k, I'm going to move down. Okay, and if I'm looking at something in this form, the vertex is hk.